Yo, time to wake 'em up!
Bonjour et bienvenue sur Discover 360. J'espère que cette chaîne vous plaira. Elle est consacrée à l'intelligence artificielle, au voyage et à la tech.
Yo, check the mic, 1, 2.
N'oubliez pas de souscrire. Bonne écoute.
Next cipher begin.
Welcome to the Explainer. Today, we're going to cut through all the noise surrounding data sovereignty. And look, forget about maps and flags for a second. We're talking about a technical blueprint for real, actual data control. This is especially important right now with powerful AI and, all these conflicting international laws shaping the entire landscape. So let's just start with a really important question. A lot of companies, maybe even you, assume that if you host your data in an EU data center, it's basically locked down in a digital fortress. But what if the person holding the keys to that fortress is an ocean away? Yeah, as we're about to find out, the answer is, well, it's a lot more complicated than you'd think. Okay, so here's our game plan for today. First, we're going to tear down this illusion that location equals security. Then we'll dig into why jurisdiction, not geography, is what really matters. And after that, this is the most important part. We're going to actually build a solution from the ground up, a whole new way of thinking about architecture. We'll even see how it lines up with regulations. And then, to finish, we'll give you a playbook you can actually use.
All right, first up, let's unpack the real problem here. See, there's a massive legal conflict happening right now in the cloud. And once you understand this clash, you'll see exactly why just picking a server in, say, Germany or France isn't the silver bullet for data protection that so many people believe it is. And this slide, wow, it just lays the whole contradiction bare. On one hand, you've got GDPR, which is super clear. You can't just hand over data because some foreign court says so. But then, on the other hand, you have the US Cloud Act, which basically forces US providers to disclose any data they control. And it doesn't matter one bit where that data is physically stored. So if you're in Europe and using a major US cloud provider, you are stuck right in the middle of this legal tug of war. So this legal mess really brings us to a critical point. The problem isn't about geography at all. It's not about the server's zip code. It's about the company's passport. It's the provider's nationality and the laws they have to follow. That's the real issue here. The Cloud Act basically says that jurisdiction follows the provider, not the data itself. So to put it simply, if a US company has control over your data, meaning they can technically access it, then they are legally on the hook to hand it over to US authorities if asked. The physical location of that server, it's completely irrelevant to their legal duty. And look, this isn't some abstract legal theory. This is real. As you can see from this quote, the providers themselves admit it. Microsoft's own legal chief in France basically said, under oath, that they just can't guarantee EU data is safe from US access. So next time you hear all that marketing talk about sovereign clouds from a US company, just remember this. They can promise you data residency, for sure, but what they can't promise is legal immunity.
Okay, so if a European server can't protect you, and the legal arguments are basically a dead end, then where do we go from here? What's the actual solution? Well, this is where we need to make a huge pivot. The answer isn't in a courtroom, it's in the code. We have to completely change how we think about protecting data from a technical standpoint. And this right here is the absolute game changer. This is the new paradigm. We can literally engineer our way out of this legal mess. Just think about it. Imagine a cloud provider gets a legal order to hand over your data. But what if all they have is a bunch of encrypted gibberish? And what if they have absolutely no way to decrypt it? Well, that legal order becomes pretty much useless, right? We can make it technically impossible for them to comply with the order in any meaningful way. Okay, so let's move from just talking about this to actually building it. Let's look at a real, tangible architectural blueprint. This is where we finally shift our focus away from location and onto layers of real technical control, a system that's designed for genuine sovereignty and compliance right from the start. So here's the big picture. Instead of thinking about one big monolithic system, I want you to imagine a set of distinct interlocking layers, kind of like an onion or a Russian doll. Each layer has one very specific job, and it's this clear separation of duties that creates an incredibly strong defense with your most sensitive data sitting safely right at the very center. Okay, let's peel back those layers one by one. First, you've got the key management layer. This is the foundation. You and only you hold the keys to the kingdom. Next is the data governance layer, which is basically the rule book. It decides who gets to do what and when. Then there's the data storage layer. Think of this as just a dumb vault. It holds your encrypted data, but it has no idea what's inside.
The fourth layer is the data access layer. This is the tough bouncer at the door, checking everyone's ID and making sure they stick to the rules. Fifth, the AI processing layer. This is like a secure black box workshop where you can work with your data without anyone peeking over your shoulder. And finally, the audit and logging layer. This is the meticulous scribe, writing down everything that happens in a way that can never be erased or changed. So the first big technology that makes all this possible is super simple but incredibly powerful. You manage your own encryption. You hold the keys. By keeping those cryptographic keys completely separate from the cloud provider's platform, you make it physically impossible for them to unlock your data. So even if they're forced to hand over the encrypted files, it's just a locked box without a key. And the second piece of the puzzle is confidential computing. Now this is a total game changer. See, we're all used to encrypting data when it's just sitting there at rest or when it's moving across the internet in transit. But what about when you're actually using it? Like when you're training an AI model? That's where confidential computing comes in. It creates this tiny, ultra-secure digital safe right on the processor, a trusted execution environment. And nobody, not even the cloud provider's own admins with root access, can see what's happening inside that safe. All right, so this architecture sounds great in theory, but does it actually solve real-world problems? Like, compliance headaches? Well, let's find out. Let's map this blueprint directly to some of the biggest European regulations that companies are struggling with right now. Because the whole point of this is to build compliance in from the ground up, not just try to slap it on at the end. And this table really makes it obvious. You've got GDPR and its tough rules on data transfers. Well, customer-managed keys give you the control you need to stop unauthorized access. Worried about DORA and depending too much on your cloud provider? These segregated layers slash that risk. Thinking ahead to the AI Act and the need to trace your training data, that immutable audit log has you covered. And for the really high security stuff, like SecNumCloud in France, confidential computing provides that technical shield against any operator access. It all just clicks into place. So let's just boil this all down to a simple checklist. These are the absolute must-haves, the non-negotiables. First, you have to classify your data. Know what's sensitive and what's not. Second, use customer-managed keys and keep them outside the cloud. Third, encrypt everything, everywhere, at rest, in transit, and in use with confidential computing. Fourth, you need really strict attribute-based access controls. And finally, you have to maintain those tamper-proof audit trails for every single thing that happens. That's it. That's your recipe for genuine control. Okay, last section. Let's turn this blueprint into something you can actually use, a playbook. Now, how you actually apply all this stuff is going to vary. It depends on your industry, your specific risks, and just as important, we need to be totally honest about the challenges and the trade-offs here. This isn't magic. Yeah, this is definitely not a one-size-fits-all kind of deal. If you're in a heavily regulated space, think banking, insurance, healthcare, you're going to need to go all in. We're talking certified environments, maybe dedicated hardware security modules for your keys, the whole shebang. But if you're in a strategic industry, like tech or manufacturing, you can be a bit more flexible. The focus there is really on protecting your crown jewels, your most important intellectual property. You can apply these heavy-duty controls to the workloads that matter most. But we have to be realistic, right? This level of control, it doesn't come for free. It adds a lot of complexity, and you're going to need people with specialized skills to manage it. The responsibility also shifts. If something's misconfigured, that's on you now, not the provider. You also risk getting locked into certain vendors for these specialized services. And yep, it can absolutely cost more, both upfront and over time. That's the trade-off. It's a strategic choice you make to get this level of sovereignty. So we've kind of come full circle, but hopefully with a totally new perspective. Real data sovereignty, it's not about picking a country from a drop-down menu on a website. It's an active, deliberate choice. It's an act of engineering. It is a capability that you have to design and build, not something you can just buy off the shelf. So the final question to leave you with is, your data's future isn't going to be defined by a map, but by its architecture. Is yours ready?